So
Are there like stuff in the ocean like coral reef?
that it's interesting that you should bring that up, because when you look at the calculations, out of that 9 gigatons, it turns out that only about, I'm going to say 4.5, but it might be 5.4 or something like that. Only a little bit more than half of that is added to the atmosphere every year, and that's a perfect segue. Where does the rest of it go? Hey Naomi, where do you think the rest of it goes?
Into the ocean.
Into the ocean, that's right. The ocean turns out to be a giant carbon sink for us. We had already talked about the fact that raindrops absorb carbon dioxide spontaneously as they fall through the air, going from water's natural 7 pH to a 5.6 pH. And it's because water and carbon dioxide, they just, they get along great. And so here's, so the ocean, the ocean absorbs roughly, oh God. The ocean absorbs roughly half of our excess carbon dioxide every year. And so we're putting out about 9 extra, the ocean's absorbing about half of that every year. And we really, to the best of my knowledge, do not know how much capacity the ocean has to keep doing that, but we do know that it absorbs a bunch load of the carbon every year. And so the load on the atmosphere would be much higher were it not for that capacity of the ocean, which, let's not forget, is 3/4 of the surface area of the Earth is ocean. And so that's a pretty tremendous resource that the ocean is providing in the sense of absorbing it so that it's not in our atmosphere. But at the same time, that also comes with a price, because as we also talked about, CO2 plus H2O gives us carbonic acid. And this is what's happening to the Earth. We're taking this carbon out of the rock, and we're putting it up here in amounts that are not even close to the 200 and some gigatons that normally exchange just from normal processes, photosynthesis, respiration, and decay, which are all roughly in balance. But we're imbalancing it by what, 4, 5, 6%, something like that every year. That's a lot. If you're a banker, 6% a year, that's good stuff. But if you're the ocean, maybe not so much. Because what we're actually doing is we are acidifying the ocean. Acidification is bad guys. Oh, yeah, sorry. Bad guys. And this is because, okay, there are a lot, I should have had a piece of chalk and a vial of acid, but basically, seashells, calcium carbonate. Acid reacts with calcium carbonate. It dissolves it away, literally dissolves it. If you take a seashell and you put it in strong acid, it will just be gone. And this is causing a huge problem for ocean organisms. In fact, in a little bit, and by a little bit I mean like 4 or 5 minutes, I'm going to show you a video that some of your colleagues made in a different year about ocean acidification. And what it's doing is 2 things. Is one, it's bad for marine organisms. Like it's not the thing that's killing the coral, but it's not helping the coral. And it could ultimately, when it reaches a certain level, be the last straw for the coral, which is already under stress from too much heat and from chemicals in the environment. Acidification is not good, but also what it's doing is it's making it harder for those organisms to actually pull calcium out of the water to add to its shells. the acid is immobilizing or absorbing or keeping, it changes the equilibrium of the reaction that these organisms use to pull these elements out to add to their own shells. And so when they're little, baby organisms just starting out and they're trying to build themselves, they are unable to do that to the same extent. So anyway, and interestingly, I'm going to point out one other thing. The level of oxygen is also dropping in the atmosphere, which is something that I'd never heard. I started reading about this and we talked about carbon dioxide building up. But if you think about it, if you're doing all this combustion uses oxygen. So there's a graph that I have. The scales are slightly different because oxygen is a much higher percentage of our atmosphere, something like 18, 19, 20, something like that, 20% of the atmosphere, whereas carbon dioxide is like 0.05% or something like that. But if you do parts per million over here, and you do change delta O2 percentage here, let's see, you have a rough increase in the amount of carbon dioxide and decrease in the amount of oxygen. Now, we're not going to run out of oxygen, don't take this the wrong way, but it is just something that somebody noticed, which is further sort of confirmation in a way that the changes our atmosphere is going through are not random changes happening for random reasons that nobody can understand. They are actually a thing. And okay, so that's good. I'm going to hit pause, and I do have a couple more what abouts, like what about this, what about that, how do we know it's true, how do we know it's not. Some big conspiracy made up by thousands and thousands of actual scientists. Okay, anyway.